Hello? Any other questions about this? Any other questions? What's the definition of a convergent sequence? I'm going to ask questions since nobody wants to ask questions. I'm asking you guys a question. Question. Guys, question. What's the definition of a countable? Oh, not countable. Convergent sequence. Dum, 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 dum.
Okay. For all epsilon greater than 0. No. Hello.
Yes.
Oh. Okay, I was saying like for all epsilon greater than 0.
Mm-hmm.
You want that definition?
Yeah, what's the difference?
Yeah. There exists an n that is a natural, like big N, that is a natural number.
Yes.
For all small n that is a natural number. Such that if small n is bigger than big N,
Mm-hmm.
then the distance between an, like a sequence, and your limit is less than epsilon.
Okay, could you explain that in English for me, in like normal language?
Like, if you, like the big N is sort of like, I can take it as a threshold, like sort of like a bound in a way.
Mm-hmm.
So after that big N, there are
a lower bound or upper bound or something.
Sorry?
A lower or upper bound.
I can say it's a lower bound because there must be small n's that are bigger than big N.
Okay.
So like after this big N, then you like your sequence, it must be bounded between epsilon L minus epsilon and L plus epsilon.
Okay, but what does bounded between L plus epsilon and L minus epsilon mean in general language?
Like your sequence must go closer to your limit as n increases.
Okay, yeah. Yeah, and your epsilon is what is defining your notion of close. What do you mean by close? I mean, some people could say 1 billion kilometers is close. Some people
It must be like really close, like 0,0 something or like 1. So like the distance between your sequence as well as your limit must be like very close, like as
yes.
0.
No, I'm just pointing out that it's the epsilon that solidifies what you mean by close. Because when you say close in the normal language, close makes sense, but in mathematics, it's like, what do you mean by close? And that's that epsilon that makes things a little bit more precise. We mean epsilon close, and we mean for any epsilon you can pick.
Yeah.
And so if we say for any epsilon, we cover things like 1 over a billion and any number you can think of, any smallish number. And so we're in the clear for whatever you mean by close. Okay. Anyone else? Okay, I'll let you ask someone else a question. Test someone else. Pass the question. Playing past the question. Ask the question.
You can like ask the question and then I can nominate.
No, they will nominate themselves.
Can you please like ask a question?
No, but ask a question that you don't know.
Sorry?
Ask a question that you don't know and ask someone else.
Oh. The Bolzano, what's
Bolzano-Weierstrass Theorem.
Hi, hello, can you hear me?
Yes.
Can you hear me?
Yes.
Yeah, the Bolzano-Weierstrass theorem is that the theorem about sequences that talks about the fact that every bounded sequence in the real space has a subsequence which is convergent.
Okay. A bounded sequence has a convergent subsequence.
Yeah.
So bounded, convergent, but so why doesn't it say that every bounded sequence has every bounded sequence is convergent? Why does it have to go down? Why does it have to go down to saying it has a convergent subsequence?
Wait, can you repeat the question?
Okay, so the Bolzano-Weierstrass theorem says every bounded sequence has a convergent subsequence, right? So my question is, why does it say that instead of saying every bounded sequence has a convergent, every bounded sequence is itself convergent? Yeah, right. Why does it have to say subsequence instead of saying it's convergent?
So why is the subsequence and not every bounded sequence itself convergent?
Yeah.
I never really thought about that.
These are very permanent questions. These are real questions to be asking yourselves.
I don't know.
Anyone?
Like,
okay. Yeah.
I don't know. I feel like because they are bounded sequences that aren't convergent, we can't necessarily say that.
Okay, so they're because they're bounded sequences. So there's bounded stuff that's not convergent. Okay.
Yes.
Could you give an example of that?
-1 to the n.
-1 to the n. That's a sequence, and it's not convergent. Why? Because why is it not convergent? Okay, almost answered you there. I shouldn't answer you.
Because although the sequence itself is bounded because it's centered around a certain region,
okay,
although it's bounded, it doesn't necessarily the sequence doesn't come to a certain point as n gets larger. Like it doesn't get closer to a certain point. It just bounces around from 1 to -1, and it never like comes together.
So it never goes towards anything in particular. Okay. Yeah, true, makes sense. So, but now Bolzano-Weierstrass says bounded means we have convergent subset, and we found out why we can't really strengthen this from bounded to convergent. But now remember, a convergent sequence is bounded, right? So you guys have a theorem like that. Convergent sequence is bounded. Yeah, you have a theorem saying a convergent sequence is bounded. Now, of course, a natural question when you have a theorem that goes from one part to in one direction. So we had theorem going convergent, bounded. The natural question is, can you come back? Can you say bounded implies convergent? And in this case, with the counterexample, we found out that we can't say that. But Bolzano-Weierstrass is basically the next best thing. It's like the best thing we can get outside that. It's almost as if Bolzano-Weierstrass, they wish they could say that bounded equals convergent, but they can't. So this is the closest they can get. Then I guess this is the closest they can get to showing convergent. I mean, you have a convergent subsequence. It's not as good as the whole thing being convergent, but it's something. It's not nothing in the whole boundedness convergence story. And that's kind of the story of Bolzano-Weierstrass. It's the next best thing to an if and only if. Okay, other question.
Wait, so can I ask?
Yes.
So the answer to the question that you asked me, the conclusion to that. So are we saying that the Bolzano-Weierstrass theorem does not say that any bounded sequence is convergent itself because of the fact that we have bounded sequences which are not convergent, so we have to come down.
Yes, it's a counterexample. But so it's kind of like it's the closest thing we could find to saying that the reverse. We can't say the reverse, but we can at least say the subsequence is a subsequence is convergent.
Oh, okay.
It's kind of like it's a really good theorem. I don't want to call it second prize, but it is kind of second prize to getting that.
Oh, okay. Yeah.
And now, what's another one? You guys did monotone convergence? Monotone convergence. Going. Okay. We ended up finding that convergent is bounded. A convergent sequence is a bounded sequence. But now we kind of hoped that a bounded sequence would be convergent, but that didn't work. So bounded does not necessarily mean convergent because we have counterexamples. But we got the next best thing, which was the Bolzano-Weierstrass theorem, which says that a bounded sequence has a convergent subsequence. So from just sequences, we did also talk about subsequences, at least you did in your class. And then now we're asking, what does the monotone convergence theorem say? Yes, what does the theorem say?
That the sequence has to be either decreasing or increasing and bounded.
Then what? Okay, increasing or decreasing and bounded means what?
It converges to a certain limit or number.
Alright, so it would say a monotone, so that's what increasing and decreasing means. A monotone sequence that is bounded. So a bounded monotone sequence and bounded is convergent. Right? So now, recognize here that we're still juggling around with two concepts, bounded and convergent. And we tried this whole convergent is bounded, and we tried this whole business of trying to make bounded convergent, but we still haven't given up, because what the monotone convergence theorem actually does is says, okay, we can't get bounded to be convergent, but is there something that we can add to bounded to make it convergent? And that's the whole, if you remove the monotone part in the theorem, you'll notice it's saying bounded implies convergent. That's really what we wanted, but it's not the case. So if we add monotone, it turns out that yes, it will work. If you add monotone to bounded, then the sequence will be convergent. So monotone is enough. Boundedness, if we add monotone, that's then enough to push us to convergence, to guarantee convergence.
Oh, I see.
Yeah. And that's kind of the story of the relation between boundedness and convergence. One goes the one way, and the other, there's a kind of, a half converse with the Bolzano-Weierstrass theorem, and the monotone convergence theorem says, what else can we do to push through and actually make it to the other side, to the convergent side? And it turns out that monotone is the property you need to just add in there, ingredient to just get to convergent.